the gyrus. You just go on down in between. So what's this membrane? What's the membrane that's attaching directly? The pia, okay? But then we can also see that we have what in there as well, a great number of blood vessels. And compared to what you're doing on the exam, what lines these blood vessels? The endothelium, which is what type of tissue? Simple squamous epithelium, okay? And so at that point, we know we're looking at the blood vessels that are down inside that as well. And so we consider most of the blood vessels are in the arachnoid, but the arachnoid does not dig into. So these are intracranial vessels, okay? So we've got a molecular layer. And now we look at all these cells, and what is that? The external granules, because those are what type of neurons? What size neurons? Didn't we do this before?
We did.
That we did.
No.
That was last Thursday. Little bitty neurons, smaller neurons, right? And then when we get to the guys where these are bigger, then what is this? Perimeters. Okay. All right. And then we can sort of kind of repeat those layers. So what do we have next? That's more like this layer. Then what do we see here? Granular layer again. That's the inner. Okay. So we're looking at layers of this cerebral cortex. Did you hear me about this afternoon? I'm going to be here for an hour. I'm going to go to this weekend.
Okay. Well, I'll do that one.
You have to leave at 1? Okay. All right. What was your question? What was your question?
What the middle one was?
The middle one. Okay, so we've got molecular, we've got granular, and then we've got Purkinje's, and we can see a few larger ones of those, right? And then we've got our next layer, which is the inner. See these big guys here? We've got some great big guys there. See these big guys?
Yeah.
Okay. And then the smaller guys in here. Remember, I told you it's kind of like looking at sperm cells, that you don't see everything perfectly in one view, right? But those are the layers. And I think molecular is pretty obvious, right? There's not a whole lot there going on there. Then the intergranular smaller cells. And what you're seeing here is that the nuclei end up being pulled away. So for that molecular, the granular layer here, these little guys. And then if you look when they slice, because you can see the line of the slicing, do you see that? And so as a result, these little cells, what did it do to them? It pushed them away from their spots. So what we see is that we see these lines, which aren't real, because the mass of the brain tissue, what we call stroma and other tissues, but the mass of the brain tissue has a different density than when you run across the cell body. Does that help? What I'm saying is look at the size of the holes. Does that help?
Can I go where?
So all the holes are running cells. Is
There are bigger holes here than there are here, right? Don't the holes look larger? So then that's the Purkinje layer.
But those are all artificial holes, right?
Yes, yes. But we can see the nucleus of the perikaryon. We can't see the cytoplasm so much. It's like it's been pushed away, and all we end up seeing is a nucleus in a space, but the space isn't a real space. Okay? But can you see distinctly, and if you look here, here, and there, can you tell there's a difference? Yes, you're shaking your head. Give me a word.
Yes.
Yes, thank you. It's just a shaky yes. Okay, very good. Now can you tell a difference where there's not holes?
Yes.
Yes?
Yes.
So what can you see there? The description I've given you so far. Well, we definitely can tell what this is, can't we? Yes, those are pyramidals, because most of them are pyramidal shape. Look at that, that's beautiful pyramidal shape. Isn't it cute? This little nucleus, little white space around the inside the nucleus, itself inside the nucleolus. It looks like a little eyeball. Okay, so now what do we have here? We have some more of these Purkinjes, but then what do we have here? We have a few, but mostly we have what? Smaller guys, okay? So what we can kind of see there is more of that six-layered effect, even though in the last slide, the first three are pretty clear. But it gives you a difference in size between these neurons and these gigantic neurons, right? Please give me some indication. Okay, thank you. Because remember, it's primarily what's there. So we don't see the molecular beautifully because there are a few neurons, but you can see granular and you can see Purkinjes quite distinctly. Now, same kind of thing again, right? So what is this layer that's attached directly there? Well, it's pushed off. It's detached, but was attached. That's the pia, okay? And so now what do we see here? Little bitty cells. There are a few large ones, but mostly little bitty cells, right? So this is, we don't see a lot of molecular. We see more granular, but we definitively see what in this area now? The Purkinjes, right? So molecular, granular, smaller ones, but then the greatest group here are the big Purkinjes. For you people who came to me, remember when we were looking at the slides of the rats and you're trying to figure out what stage it is and you want it just to be one cell, but it's really a mixture of all the cell types? Yeah. Now, this is a different type of staining, but we can see from the far left, the molecular, we're coming into granular, and then we see these great and crazy things, and so then that's more of the Purkinje cell. But it shows more their processes than the perikaryotes. Now this one's great. Look at these guys. Now, if you have a look from the bottom up, what do you think the bottom is? The what? This is granular. Very good. See these little dudes? Right? But you see all the little processes? And then that would be where what is? That's molecular. This is granular. This is definitively Purkinje. Isn't that crazy? I mean, look at this guy. It's like a bad hair day. Ah! See how crazy it is? That's all those little processes, all those attachments, all of the synaptic connections between those neurons. And that's what we grow. We make these guys have an even worse hair day by learning, by increasing the synaptic connections, by making more dendritic growth of the neurons themselves. I love him. He's really cool. Okay. So these are called basket cells, right? Basket. B-A-S-K-E-T, basket cells. Isn't he kind of cool? So you can see the perikaryon or cell body. You can see all the massive number of dendritic connections, and I can't even attempt to say which one is the axonal exiting from that neuron. But if you look at all these little wavings that you see in the stroma of the brain itself, see, you see this big massive thing, but what's all of this stuff? These are where we have massive numbers of connections. And if you look, everybody look. Okay. Look. Rook across me. These are the massive numbers of connections. See this dense area right here? Guess what all those dense areas are? Those are synapses. Those are synapses. So this guy, look at the huge number of connections there are. So if you look along this, I mean, this guy's absolutely crazy. If you look at the number of synaptic connections, and that's what all these guys are down here, and that's what we grow with learning. We increase the density of that communication mass. And that little dark dot shows those synaptic connections with all of these little guys sending the information towards this cell body. So we talk about the nervous system as being your primary integrating and coordinating system of the body, correct? And what's the second one? Endocrine, all right? This gives you that concept of that connectivity. And in just a minute, when we move to the cerebellum, you're going to see there, we see the largest neurons in the brain, and they're actually called the Purkinje cells there. The Purkinje cells of the cerebellum are the largest in the central nervous system. And they have as many as 250,000 synapses. Now think about that. One cell, so if you look here at this guy, I can't imagine, this is a gigantic number too, but if you look here at this cell body, this is where the integration is going on. You're the CEO, you're the head of this company, and you've got 250,000 employees, or in this case, I don't know how many it ends up being, it's a pretty gigantic number, right? It's a big complex for sure, and they're all giving you information. And the information that you're going to send out, if this was the axonal segment, is the integration of all that information coming in. That's what I want you to be totally amazed by. When you think X response, that has been integrated from, in this case, a massive amount of information coming in to that neuron. So say, wow, or that's crazy.
That's crazy.
Good, thank you, that made me feel better. And now we move on to the hindbrain. So what is the hindbrain? So there's a blank slide, and now we're moving to the hindbrain. So where are we? Where do you think we are? What do you think this big thing is? That's the cerebellum. What's the cerebellum? What's 3? Medulla oblongata, right? What is the area of, it's kind of pushing it together. Should be an extra part of the cerebellum. Right. There's something wrong there. That looks like, I think that's spinal cord. That's medulla, and that is part of the pons. Yes, okay, so look up here, yeah. And then inside we can see a big dentate nucleus that's found inside the cerebellum. And it looks like a tooth, so thus they call it the dentate nucleus. But this is all the white matter, the gray matter, what are these little folds called? The fovea. And these connections with the brain stem, what are they called? The peduncles. That's right, very good. Now, what does the cerebellum do? What's its primary job?
Coordination.
Balance, posture, coordination. This time coordination means motor coordination, physically being able to move. So any information that's going up to the cerebrum, to the motor cortex, or any information that's coming down from the motor cortex through the brainstem, what does it go through? The cerebellum. All right, so the cerebellum is monitoring all of that motor information. Cerebellum is also getting information from what? gets information from the inner ear. What two portions of the inner ear? Semicircular canals and the vestibule. What are the receptors in those called? Does anyone remember? What are the receptors? What's the little receptor areas in the vestibule? The sac, well, they're around here. The saccule and the utricle, right? And then these little enlarged areas at the bottom of each of the semicircular canals are called the ampullae. And what do we find in the ampullae? The cristae ampullaris, those receptors there, right? And the receptors in the saccule and utricle look like this, right? You have a little basal membrane with these otoliths or statoconium, which are little rocks, calcium carbonate granules inside the head. So then these two respond to, or give us static equilibrium. This one gives us dynamic equilibrium, so when we're spinning. So we're either going forward or we're going backwards. So we're going this way, that way, or this way. Does that make sense? To give us all three axes there of movement. And then this guy gives us just movements of the head. So forward and to the side and backwards, relationship of the head to the rest of the body. And that's what this guy's doing. So the cerebellum is interpreting all that information. The cerebellum also gets information from another of your primary senses. What's your other primary senses getting information from? Your sight, vision, balance. So vision and balance are uniquely joined. So all I have to do is stand you upright and have you close your eyes. So you're having a prayer, right? And then there's this guy who's, remember, catching up on his prayer line, so he decides that the benediction is going to be 6 minutes long, and you guys are okay because your feet are flat on the floor but wearing high heels, and what's happening? Right? Tilt, tilt, tilt. So I learned to just grasp the pew in front of me, right? Hold on. So now I've increased my base of support. So not only my feet, but also now my hands, in case that person is going to catch up, and then we've got to. Right? So our preacher always says the only thing that's standing between me and you and your lunch is how long I'm going to talk. So, I was laughing at that. Oh, okay, let me go back to the center. What is just medial to number 2? The what? Yeah, that. Well, this is this actually an artery? It's along the base of the brain. Basilar, the basilar. And what branched into it? The vertebral arteries. And what will it communicate with? Posterior communicating to posterior cerebrals. Remember that from last time? A little bit maybe? Okay. So anything that you can see, always look to see if there are other things that are visible there that I can bring in to the discussion. Alright, so now we have a section of the cerebellum, and this time in that section of cerebellum you can see clearly the beautiful arbor vitae, that white matter that goes inside. You can see the fovea very distinctively, and you can see the big tooth-like nucleus called what? The dentate nucleus right here, all right? But this is the white matter, that patterning. The pattern looks like a tree, so they called it the tree of life. And here you can see the beautiful invaginations, etc., of the fovea of the cerebellum itself, all right? And then what would be this mass of stuff right here coming out? Caroline, you said before. The peduncles, that's right. The peduncles. And then here we go into a micrograph of the cerebellum. And let's see, if you look at this cerebellum, look on page 2 of your large handout.
Oh, that guy is.
Charlie took care of you, isn't he, sweetie?
Always, nothing's ever good enough. I'm sure.
And I want you to know, Miss Alexis did an absolutely great job on Friday. She never used her notes or anything. Wasn't that great?
Yeah. Very good.
We're excited for you. Are y'all getting real tired?
It's a little.
Oh, you just lost track of us.
What's the bag?
Edward, do you have another copy of this solicitor?
Alexis, can you break that document into little pieces?
Yeah, that's what I think I'm gonna try to do, is I'm gonna try to cut it.
Or do you have a zip drive you would give her and just let her download it?
I have one at home actually that I could use.
Do you have a zip drive? You don't have to do it. Anybody have a zip drive?